Today we are going to discuss about the design thinking concept on sampling in digital communication. So before going to see this design thinking approach, we have to know what are all the stages available in the design thinking. Can anyone tell me what are all the stages in the design thinking?
So there are the 5 stages, ma'am. Prototype, define, ideate,
Empathy.
empathy. Yes.
So we are having 5 stages in the design thinking concept. The first one is empathize part. So what do you mean by empathize?
So let me empathize this part, ma'am. So first of all, why do we need a sampling in this? So in real life, there is a signals like voice, some recorded videos or sensors data, or the analog, right? So but in digital devices like computers or phones, it turns into a numbers, and so the big question is, how do we need how can we change the analog signal into the digital form without losing any important details in this. So for example, when we speaking to someone in a phone call, our voice will be captured, and the sound, the natural sound, when we speaking to them, the natural sound, it will changing into the digital form. So that's why we need a sampling to have that same natural sound to pass into the another person. So that's why we need a sampling in this.
So without any loss of information.
Yes,
so for that we are going for the digitized one. So in digitized one, the main purpose of being converting the analog signal into digital will be your sampling part. So we are taking what are all the customer needs. That will be is the empathized part. So what is the next?
The next one is define, ma'am. So like we're going to define the problem statement. So when we work with the real world signals like voice, music and sensor data, they are analog in nature and continuous in time and amplitude. But computers and digital systems can only handle discrete values. So we need to sample the analog signals and take measurement at regular intervals, and later we have to reconstruct it back. So the core problem is how to sample the signal in such way that after reconstruction it look like original signal without distortion. The main key issue is aliasing and Enquist's theorem.
So in the define part, we have to select what is the problem, we have to identify that problem, and we have to give the solutions. So for that we have to take any one of the problem. So without any distortions, it has to be converted. So what is the next stage?
There are different sampling strategies are used in digital communication. There are 2 types, uniform and non-uniform sampling. In uniform sampling, the samples are at equal interval, and in non-uniform sampling, samples.
So the intervals will not be same.
It
will be irregular. So that is the non-uniform sampling. In uniform quantization, it will be same at regular intervals. In non-uniform, it will not be same. So we have to rectify that. So that is what in ideate part we are giving some of the types of sampling in order to avoid the distortion. So for that we are going for 2 types of sampling. One is uniform, another one will be the non-uniform. So what is the next?
So last one is the prototype. Use in the ADC analog to digital converter to sample the signal. For example, the human voice is normally to below the 4 kilohertz. 4 kilohertz. According to the Nyquist prototype, use an ADC analog to digital converter to sample the signal. For example, the human's voices normally frequency has 4 kilohertz. According to the Nyquist rule, we must sample the at least twice that the 8 kilohertz. Use the sample and hold the circuit to maintain the sample.
to prevent the error, sample.
Okay, so as we discussed the design thinking concept on the sampling topic, we know that we have to avoid the distortion and we have to retrieve the original information. Suppose if there is any distortion available in the sampling, we can go for some of the techniques. So we are going for the uniform as well as the non-uniform in order to avoid the distortion. At the same time, we are using many of the circuits such as sample and hold circuits. So these are all the circuit. It will prevent the distortion, and finally we are getting the original signal as it is. Are you clear with this? Okay, thank you.
Thank you.